Exercise 3.4. What's the vt, the x component, for the velocity of the swirl as a function of time? This one I will explain to you why I put this here. The velocity, right now it asks for the velocity of the swirl as a function of time. Since it's looking for the x component, because right here it's asking for the x component. Now, they give you this equation right here. What you need to do is find x, and the only way to do it is by knowing where to find it. It's not in this whole entire equation because that's asking for radians. The only way to find out which one is x and which one is y is by the letter I or j. I is symbolized for x and j is symbolizing for y. So since we got that out of the way, so let's do this. So bracket 2.80 meter over seconds plus 0.036 meter over seconds square, and there's a t in over here, so we're gonna put that t square. Since they're asking for to find the x components, what you need to do is square root, or actually not square root, but square 0.0360, because that will take care of the square. So you will get 0.280 meter over second plus 0.072 meter over second square with t right here. Same goes for this one. It's asking for the y component. You focus on the y. The y is the j. So let's see here, 0.190 meter over square over cube, and obviously t is cube 3. So what you need to do is you need to times, well actually it's like this, it's like 0.0190 times 3, because you need to time by 3. So since that 0.0190 times 3 equals 0.0570 meter over seconds cube with t square. So that, since you got the 3, so you move the 3 out here, so that's how you get. It's like a derivative. So this one here is asked for they give you the t equals seconds, equals 6 seconds. How far the swirl from the initial position? Since they give us t, and here's the equation I wrote down, we just need to plug in the t into the equation. So 0.0280 times 6 plus 0.0 times this times 6 square, so square plus 0.0190 square cube over 3. Remember that this one right here represent I, so we're going to put I right here. So bracket, this would be I, and this will be j. So bracket j. This represent x, this represent y. So what we need to do is that we need to solve them all together. So if I solve this equation together for I will get 2.976 I. And for J, I'll get 4.104 J. But we're not done over here just yet, so let me put it here. Since we got two equations, and it asks for the initial position, sorry, what we need to do is plug them in together into the equation to find the initial position. So the equation will be square root over I square plus J square. Equal that, so let's plug it into our equation. So in here, 2.976. Here, square that plus 4.104. Square that. We will get ourselves 5.069. Rounded to the number, and this will get equal to 5.707. So this one here, since it's asking for what's the magnitude of the swirl velocity, remember that v equals dr over dt. So what we need to do is write our equation, obviously. 0. I should have wrote down before I record, is 0. T plus 0.036c go t square, and for our answer for another one, well, this was for I, so we'll put that here, I plus 0.0190, and for t cubed here, and this was for J. What we need to do is derivative it. So if we derivative 0.280, we'll get 0.280. And then if we derivative 0.0360 t squared, we'll get 0.0720 with t. This is for I. So remember that. This is for I. Oh. And same thing for the other side, the one we just did for I. Is 0.0190 times 3 will equal, here, will equal 2, yeah, 0.0, let me write down so it'll be more easier for me, times 3 over t squared. We take care of the I first. We will get ourselves 0.712 over I plus, for J, we'll get ourselves 2.052. Let me put a bracket here, or the parentheses, J. We will get our, remember, same thing what we did from our initial position, because this is a set of rules that we need to do to also find the velocity. So it will be square root 0.712 square plus 2.052 square. We will get ourselves 2.172 meter over seconds. Also, this is meter. So this one stands for what's the direction in quote in degrees of counterclockwise from plus x-axis of the swirl velocity. The swirl velocity. Same things right here. Because this one here is asks for swirl velocity, but this one asks for magnitude. This one's asking for the direction. So I haven't wrote it down, but this is tangent equals, and knowing tangent, and since this is also counterclockwise, this would be ace tangent. So ace tangent, and what we need to do to plug in our ace tangent is to plug in what we initially have for j and I in our previous equation question, which would be this one right here. Let me highlight right here. This would be 0.12 I and 2.052 j. So we divide it. So 2.052 j, because the j would be on top and over the I, so it would be 0.712. So let's take care of the stuff that inside the ace tangent. This will equal to 2.882, which remember we need to put that in our ace tangent. So ace tangent over 2.82 equals 70.86.